recording. There we go. So we're looking at acid naming. They're based on the names of ions, and they're based on ite, or ide. I would like you to tell your partner, when you have the ite ending, what is a mnemonic that can help you remember how to name the acid? My Sprite, which I should capitalize, I guess, because it's a what you call it word, proper noun. My Sprite is delicious. So what that means is when you have an ion that ends in ite, you will change the ending of the name so that it becomes os, O-U-S. So for example, if we had the ion NO2 minus, which is nitrite, we're actually going to do a little bit of formula making as well while we're here. What we've got is we have a positive ion and we have a negative ion. We have a +1 and a -1. Do those charges cancel out? Does +1 cancel out -1? Yes. And if that's the case, we only need one of each ion. So if we were to write the acid, we would write it as HNO2, where we just have one hydrogen and NO2. Now the name of this acid, because we had nitrite, it becomes nitrous. Okay, ite becomes us. Nitrite becomes nitrous, and then we add the word acid. Now there's a couple of kind of weird ones. A couple elements need extra syllables. S needs like sulfur, and P needs or. So let's say that we had, for example, SO3 2-. We can look that one up on our table, and its name is sulfite. Sulfite. All acids contain the H+ ion, so that's the other part of the acid, is the H+ ion. Do our charges balance each other out? Does the total positive equal the total negative? No. So I need to have one more hydrogen so that when I add those two H+ together, I get 2+ to cancel out the 2-, because every compound, the net charge should always equal 0. Okay, so we need 2 hydrogens to go with our 1 sulfite. So our formula for the acid would be H2SO3. Now normally, if we were following just the us rule, we would look at sulfite and say, oh, that's easy, that must be sulfus acid. Except that sulfur needs So in front of the us, and right after the sulf. So it's not going to be sulfous acid. It's going to be sulfuric acid. So we still have the us because it was sulfite, but we need that extra because it's sulfur, and you just have to remember that. I'm sorry, it's just life's like that sometimes, okay? And it's not just sulfur that is one of the exceptions, it's also phosphorus, which needs an or. So let's look at the phosphite ion. PO3, 3 minus is phosphite. What ion do we have to add to make it an acid? H plus, so we need to have some H pluses to go with it. How many H pluses do we need to go with our PO4 3 minus? We need 3 of them because that's going to give us 3 positive that balances out the 3 negative. All right, so our formula then for our acid is H3PO3, and we need to take the ite and turn it into us. So phos acid, except that, what did I forget? Yeah, this one needs OR. So not phosphorus acid, but phosphor acid. Those are the only two that are weird though, the sulfur and the phosphorus-based ions, okay? And that's going to apply for your ite ions, your ate ions, and your ide ions. If they are sulfur or phosphorus-based, they will have that extra syllable for sulfur and or for phosphorus, okay? All right, that was our ite ions. Ooh, I should have put this a little further over. Or maybe I should just go down. Maybe I should just keep going straight down. Let's do our ate ions now. And tell your partner if you can remember the mnemonic for remembering the ate ions. I ate something. You remember it? Icky. I ate something icky. So if I have, again, I could try my NO3 minus is nitrate. So if I put an H plus with it now, do I have the right number of H's to go with the NO3? Yes, because I have +1 and -1. So those cancel, the charges cancel out, and we have HNO3, and the name of that acid would be we replace the 8 with an ic, so it becomes nitric acid. And you'll notice, did any of these have a hydro in the front? No, there's no hydros for our ate and ite ions. Okay, so don't get too excited by the hydro. There's only a few acids that actually have hydro at the front. All right, let's try now again. Remember, sulfur needs and phosphorus needs ore. So let's try SO4 2-, which is sulfate. How many hydrogens do we need? 2. We would have H2SO4, and we might want it to be sulfic acid. That might be what we'd think originally, but it's not, because we need that extra so it's going to be sulfuric. Sulfuric, we usually say sulfuric acid. And just because we should, what if we had phosphate? PO4 3- is phosphate. So we're going to have that ick ending because I ate something icky, but because it's phosphate, I need to have the extra or, so I'm going to name it, I have H3, PO4, 3 H pluses to go with my 3- there, and that would be phosphoric acid. Our last type of acid are based on the ide ions. So for example, we might have I-, and the name of I- is iodide. Ooh, tell your partner if you remember the mnemonic for ide ions. My ride has hydraulics. Now, this is not maybe the best mnemonic in the world because, number one, hydraulics is spelled with an AU, but we're going to spell it with an O because the kind of hydro we want in our formula is hydro with an O. Plus, how many of you actually understand what hydraulics are in a car? Some of you do, and that will help you. The rest of you who are like, what the heck are hydraulics in a car? Maybe this won't help you remember, but maybe you'll just remember the sentence, my ride has hydraulics. Right? So even if you don't really understand what they are, maybe you can just remember that sentence and it will help you remember. Okay? So in this case, we need a hydro and an ick. So we're going to take the front of the word, the stem of the word, the iode. Okay? We're going to take off the ide. Let me put it together with hydrogen. We now have, oh, look. Hi. No, nobody found that funny. Okay, it's all right. We could have high, we could have nitrogen monoxide, no. I don't know. Not a lot of words you can spell. Okay. Anyway, we got our hydrogen iodide, but we won't name it that because it's an acid. So this would be hydro, right? And then we're going to take the iode, and then we'll replace the ide with the ick. Hydro, iode, ick, acid. Cn-. That is cyanide. We need one hydrogen to go with that, so we have HCN. That would be hydro cyan, and then we'll replace the "ide" with an "ic," acid. So we have the cyan, we put hydro in front, we put "ic" at the end, and that's our acid name, hydrocyanic acid. Now, don't forget, still with the sulfur and the phosphorus, if I have S2 minus, how many hydrogens do I need? 2. So we have H2S. S is sulfide, but remember sulfur needs an So that's going to be hydrosulfuric acid. And we would have phosphide, P3 minus, needs how many hydrogen? 3. Okay, so now we have H3P, but this is phosphide. My ride has hydraulics, okay, and we have phosphorus, so phosphorus needs an extra "or," so that's going to be phosphoric acid. Last but not least, we're going to take a look at some organic acids, and just before we do this, I would like you to come up and grab, if you do not already have it, one of these white handouts from the basket. So on the front page of that handout, you'll see the ions are arranged by alphabet. But if you flip it over, the ions are arranged by charge. And I would like you to flip to the back page because when we go there, that's the one. When we go to the back of that page, you can see at the very bottom, it says organic acids, so the organic ions. So those are the ones that you're going to use when you see a special group, and that group is going to be the COO. COO. So when you're doing acids, sometimes we'll use different ions than are on the pink sheet. The pink sheet's good for everything else, but acids, you might need to use the white sheet, okay? And one of the places you might need to use that for is for your organic ions. So if we have these organic acids that are based on carbon, they don't look like most other acids. Most acids start with H. Organic acids do not start with H, they end in COOH. Instead, okay? So our most common example might be CH3COOH. So if you see this group here, COOH, that tells you that you have an acid. Now we could draw the Lewis structure for this, where we have a carbon with 3 hydrogens attached. Okay, it's attached to a second carbon here, and that carbon has a double bond O, and then it has a bond to an O, and then that O bonds to an H. You don't need to be able to draw that, okay? I'm just showing it to you because what I want to point out is that this section here, that is the CH3COO minus section of the acid. I would like you to go and look up the name of that ion. CH3COO minus. Who is that? That is acetate. Okay, now this is a little bit unusual because this right here, so here's our acetate and here is our H plus. Normally, where do cations go in formulas? Normally, the positive ion goes first in a name or formula. But organic acids are the exception. Okay, and if you're like, I don't know, do positive ions always go first in the formula? Think about sodium chloride, NaCl. Yes, the positive ion comes first. If we had hydrochloric acid, if we had HCl, that would be our H positive and our chloride negative, so the H comes first, the positive ion comes first. But in organic acids, the negative ion is first and then the hydrogen is at the end. It just has to do with the structure of the molecule, and as you get more familiar with them, you'll just get more used to it, okay? But for now, just something to learn. So here we have acetate. It's an 8 ion. And so we would then name this acetic acid because I ate something icky. C6H5COOH. You look at this compound and you say, I know that it is an acid because I have the Cu group. Okay, if you have the Cu group, you have an acid. COOH, Cu. So I would like you to, what you do is you take everything up to the COO. Is the anion. And then of course this is the H plus. So I would like you to go look up C6H5COO minus. What is the name of C6H5COO minus? Benzoate. And you won't find that one on your pink sheet. It's one of the ones that you would need to use your expanded ion list for. So we have benzoate, so this would then become benzoic acid. And in fact, all the organic acids are all 8s, so they will all be just ic acids. Okay? And I'm going to abandon you to do your quizzes. I'm not abandoning you, I'll still be here, but I'm going to stop talking at you in a moment. But just before I do, just in case some people are getting on to quizzes 7 and 8 where you are writing formulas, I'm just going to give you one example. Let's say we had manganese 3 carbonate. And I said, go write me the formula. You may or may not remember this from last year, so we're going to go through it. The first thing you do is you write the ions and the charges. It's actually just like going backwards from when we named compounds. So we're going to say I have manganese. Manganese is in the gray zone, so I do not know its charge. What is the charge of manganese here? It's 3 because that 3 tells me that I have a 3+ charge. Carbonate, you just go look up carbonate, CO3, 2-, and then you need to balance the charge, which means make the positive equal the negative. So find the lowest common multiple. And in this case, it's going to be of 3 and 2. What's the LCM of 3 and 2? 6. So we want this to equal 6 positive, and we want this to equal 6 negative. So how many manganeses do we need to get 6 positive? We need 2 of them. And how many carbonates do we need to get 6 negative? 3. You don't have to write this out every time, obviously, but if it helps you, go for it. Okay, so what that tells us now is that we have 1, 2 manganese, so Mn2, and we have 1, 2, 3 carbonates. So that's going to be CO3, and then we put it in brackets because we have 3 of that entire group. So Mn2, CO3, 3. We'll go over that a little more tomorrow if anyone needs a refresher on it, but just in case you're getting to that quiz today, at least you've seen it, okay? Your first job today is to get your name off this board. If your name is on this board, it means you haven't finished one of quizzes 2, 3, and 4, one or more of quizzes 2, 3, and 4. And if you're on there and you don't finish them by today, then I would like you to please come by either after school today or tomorrow during flex to get caught up so you don't get too far behind. Okay? And I need to find those other quizzes. Oh, there's Daniel. Daniel. The other ones. Isaiah. So you're aiming for a minimum of quiz 5 today, but like, go for it. Go beyond. Yeah. find that. And do you need a periodic table?